Hello and welcome. With the news of National Science Day celebration, novel biogas technology and many exciting others, I am Aishwarya Kapoor with you and I welcome you all to a fresh new episode of Science Monitor, our weekly update on all that is happening in the field of science and technology in and around the country. Well, we will see some fascinating happenings in the field of science in today's episode, but first let's take a look at the headlines. Country celebrates the National Science Day, awards best scientific efforts. WHO's deadly list, most resistant priority pathogens identified. Food equals energy, novel technique to develop biogas from leftover food. First NASA mission to fly to Sun aims to answer crucial questions. The National Science Day that marks the birth of the Raman effect is the celebration of science and its immense contributions. For ages, it was believed that the blue color of sea was due to the reflection of the sky. Until in 1928, Sir C.V. Raman proved that the blue color was due to scattering of light by water. Well, the National Science Day marks this historic discovery, which today is known as the Raman effect, a celebration of science and its immense contributions. The National Science Day was celebrated across the nation on 28th of February with immense enthusiasm.
Like every year, commemorating the discovery of the Raman effect, the country on 28th February celebrated the National Science Day with great enthusiasm and cheer. The National Council for Science and Technology Communication, the nodal agency under the aegis of the Department of Science and Technology, responsible for coordinating National Science Day celebrations, organized a variety of activities to promote this cause. The event, which saw the participation of Union Minister of Science and Technology and Ministry of Earth Sciences, Dr. Harsh Vardhan, and Professor Ashutosh Sharma, Secretary, DST, also saw the declaration of national awards for the year 2016 for outstanding contributions towards science and technology popularization. The winners are Kalinga Foundation Trust and Dr. N.V. Padma Srivastav for National Award for Outstanding Efforts in Science and Technology Communication.
Known scientists of the world, one is selected every year, and he has contribution for popularizing science among common people, either by writing or by laboratory or by print media or press media, television, anywhere. We are giving scholarship to children, and we are giving money for the difficult diseases like heart, neurology or cancer, like that. And apart from that, we give this Kalinga Prize.
Dr. Ranjit Singh and Dr. Subhashri Desikang for the National Award for Outstanding Efforts in Science and Technology Communication through print media, including books and magazines.
Humans are different from other animals in that they have reached the top of the pyramid. That involves not just power but also responsibility. And to access this responsibility well, you need to understand science, and people need to understand science, and things have to be a collective effort. So it's not just important to communicate science, but it should be a day where we think about how to make India a country where everybody thinks scientifically and can participate in decision making.
Delhi State Science Teachers Forum and Sri Sanjay Bapu Rao Pujari for the National Award for Outstanding Efforts in Science and Technology Popularization among Children. Professor Shaili Avasthi for the National Award for Outstanding Efforts in Science and Technology Communication through innovative and traditional methods. And Dr. Anil Tripathi and Sri G.S. Unni Krishnan Nair for the National Award for Outstanding Efforts in Science and Technology Communication in the Electronic Medium. The winners were presented cash prizes, mementos and citations by the dignitaries. While various research institutes and colleges celebrated the National Science Day in their own unique ways, the Indian Academy of Sciences hosted an exclusive National Science Day event for students. School students from various parts of the city participated in a visit to the renowned C.V. Raman Museum, located in the Raman Research Institute, Bangalore, along with hand-on experiment sessions.
Mild fever with throat infection? Take an erythromycin or amoxicillin. A case of food poisoning? Well, pop in ciprofloxacin. Well, such simple self-medication tips are a familiar trend among a majority of us. But as we have randomly ingested antibiotics, microbes have evolved and developed a deadly resistance to antibiotics. Well, today some of the most potent antibiotics fail in front of these super bugs. Now, WHO for the first time has come up with a list of deadly resistant pathogens that need to be tackled as an urgent priority.
This is the era of superbugs, the tiny bacteria capable of changing faster than the drugs available to treat them. With our indiscriminate use of antibiotics, these microbes have developed serious antibiotic resistance and are a major healthcare challenge today. The recent list of antibiotic-resistant priority pathogens by WHO is an indicator of how serious this problem is. For the first time, WHO has come up with a catalogue of 12 families of bacteria that pose the greatest threat to humanity as of now. It divides 12 families of bacteria into 3 categories based on the urgency of need for new antibiotics.
This is one of the several WHO work streams to address antimicrobial resistance, which must be tackled from several angles and in a comprehensive way. This new global list clearly sets 3 priorities for research and development of new antibiotics: critical, high, or medium, to convey the level of urgency for the antibiotics needed.
The critical priority group includes 3 families of multi-drug resistant bacteria that pose a threat to hospital patients. It includes Acinetobacter and various Enterobacteriaceae, which often lead to bloodstream infections and pneumonia. These bacteria have become resistant to a large number of antibiotics, including carbapenems and 3rd-generation cephalosporins, the best available antibiotics for treating multi-drug resistant bacteria. The high priority group includes 6 families, namely Enterococcus, Staphylococcus, Helicobacter, Salmonella, Neisseria, and Campylobacter. The medium priority group includes Streptococcus, Haemophilus, and Shigella spp. The drug-resistant tuberculosis is not included in the list, as there is already consensus on its being a top R&D priority. The list has been developed in collaboration with the Division of Infectious Diseases at the University of Tübingen, Germany. Factors such as level of resistance to treatment, mortality rates, prevalence in community, and burden on the health system have been considered to rank these pathogens. The WHO list is intended to guide and promote innovation in the research and development of new antibiotics, and also to encourage governments to figure out how to incentivize research.
Food is the source of energy, and leftover food is common in our usual households and during events like weddings. Usually this is either fed to cattle or is thrown away. But leftover and spoiled food can also generate energy. Proving this is the innovative biogas plant, which processes waste food to give back energy.
Leftover or spoiled food, which is either fed to domestic animals or thrown away, are common occurrences of almost every household. Wouldn't it be interesting if we could develop something productive out of such waste food? Along the same lines, the researchers of the Indian Institute of Engineering Science and Technology, Shibpur, have developed a novel biogas plant which converts kitchen waste to energy through a process called anaerobic digestion or fermentation. Anaerobic refers to an oxidation process in the absence of oxygen, wherein organic molecules are converted into biogas that is 60% methane and 40% carbon dioxide. The biogas is produced in 3 steps, namely hydrolysis, acidogenesis and methanogenesis.
There are 2 trolleys who collect the kitchen waste and the food waste from different hostels and different residential places and bring them to our biogas units, where they are properly segregated and shredded and put into the machine, where from that, the mix goes into the biodigester, and from the digester the gas is produced, and that biogas is then fed to the engine, which then produces electricity.
In this process, there is a provision for collecting kitchen waste from hostels, residential places and hotels where daily a large amount of kitchen waste is generated. The wastes are mixed with water in a large plant with a 1000 kg capacity to form a liquid slurry, which is channeled to another tank and left to ferment for 40 to 45 days. During the process, the water in the waste is separated. During fermentation, methane gas is produced in the tank, which is separated out and used as fuel in generators and cooking. What is more important is that besides being eco-friendly and producing clean fuel, the byproducts of fermentation can be used as green manure for crops.
जो वेस्ट है वो एक अच्छा वाला फर्टिलाइजर है, वो फर्टिलाइजर कोई खेती में यूज करेगा तो उसका दूसरा कोई फर्टिलाइजर का जरूरत नहीं है। गांव में क्या होता है, उसे जनरेटर का जरूरत नहीं है, उसका कॉस्टिंग बहुत बढ़ जाता है, इसीलिए क्या होता है गैस डायरेक्ट जला के वो थर्मल यूज करता है। आपका जो खाना बनाता है, जो में अपना जो आग लगता है, हीट जरूरत है, वो सब काम कर सकता है।
This kind of organic processing facility to generate biogas is indeed a cost-effective and eco-friendly method to generate a high-quality renewable energy with valuable byproducts.
Sun, the source of energy on Earth and one of the most intriguing celestial objects of our solar system. While we have managed to learn much about the moon and even have landed on it, reaching Sun remains an impossible feat, one which can answer many fascinating questions about it. But soon, NASA will attempt to reach as close to the Sun as possible to answer some of these solar questions.
We all know that the Sun, the star of our solar system, is powered by a continuous chain of nuclear fusion that converts hydrogen nuclei into helium. It is estimated that in its core, the Sun fuses nearly 620 million metric tons of hydrogen each second. But one question that has puzzled researchers over the years is that why is the surface of the sun not as hot as its atmosphere? Yes, according to present data, the surface temperature of sun is only about 5,500 degrees Celsius, while its atmosphere is about 2 million degrees Celsius, a contradiction which has baffled researchers. Seeking an answer to this fascinating question, NASA is geared up to send its first robotic spacecraft to the sun next year. While this is the first mission to fly to the sun, it doesn't mean that the spacecraft can get to the very surface of the sun, a feat, as of now, impossible. According to sources, the robotic spacecraft is designed to get within 6 million kilometers of the sun to probe its atmosphere. The mission aims to answer 3 crucial questions about the sun. Firstly, it will try to understand why the surface of the sun, called the photosphere, is not as hot as its atmosphere, called the corona. It would also try to understand how solar wind gets its speed and why the sun occasionally emits high-energy particles that are dangerous to unprotected astronauts and spacecraft. According to reports, the unmanned probe will have special heat tubes called thermal radiators that will radiate heat that permeates the heat shield to open space so that it does not affect the heat-sensitive instruments.
And now it is time to take a very short break. We'll be right back with more science news. Keep watching Science Monitor.
Optical fiber today is our major activity. We have developed an equivalent Indian clay. We export 40% of our production in this country of these tiles, and there is no imported component today in that tile. The savings estimated is around 2,100 crores per year, that too in foreign exchange.
Watch Eureka with Dr. K. Muralidharan, Director, CSIR, Central Glass and Ceramic Research Institute, only on Rajya Sabha Television.
Welcome back after the break. You're watching Science Monitor. Let us now have a look at some important science and technology activities happening in India and abroad in our next segment, Science Express.
ISRO is all gearing up for the launch of Chandrayaan-2. According to recent reports, tests for controlled soft landing of Chandrayaan-2 on the surface of the moon is underway in a simulated environment. This announcement was made by ISRO Chairman A.S. Kiran Kumar recently. The Chandrayaan-2 mission is currently planned for the first quarter of 2018. Mexican deserts have been a source of well-preserved fossils. Adding to the collection is the complete skeleton of a new marine reptile. The reptile, named Mauriciosaurus fernandezi, is reported to be 93 million years old and is the first fossil to show soft skeletal tissue structure from its neck, flippers, torso and tail. It is believed to be a marine reptile 6 feet long and with a flipper span of nearly 4 feet. Knowledge of life on Mars could be gathered from Chile's Atacama Desert, believe scientists. This is based on the fact that Atacama, the world's most arid region and with a climate similar to that of Mars, harbor life forms even in absence of water. Scientists found bacteria in the Atacama which can withstand the intense sun and sustain life in the arid region without water. The findings are being extrapolated by NASA, who will study the possibility of life on Mars. In the most recent find, researchers have dug up microfossils up to almost 4.3 billion years old, found in Hudson Bay shoreline in Canada. The microfossils could be the oldest evidence of life on Earth. Based on this, scientists postulate that the hydrothermal vents of Hudson Bay may have been the cradle of life on Earth relatively soon after the planet was formed.
From nabbing criminals, explosives, hazardous chemicals and gases to pharmaceuticals, material sciences, petroleum industry and chemical industries, Raman effect finds application in many fields. As the nation celebrates yet another Science Day dedicated to this genius mind and his findings, well, let us try to understand what actually Raman effect is and how this has found applications in many fields.
India today, a leading champion of science and technology, has a great scientific legacy to be proud of. Of the many ingenious minds of India, whom the world follows the lead, one name stands out, and that is Sir Chandrasekhar Venkat Raman. Sir C.V. Raman, as he was popularly known, the discoverer of fundamental Raman effect and a scientific leader par excellence, was the first Asian and Indian to receive the most coveted prize of science, the Nobel Prize in 1930. Raman was awarded the Nobel Prize for the probing the explanation of the blue color of the sea, the Raman effect, which changed the course of physics thereafter. Countless men must have observed the blue color of the sea since ancient times, but it took the genius of C.V. Raman to decipher the natural law behind this seemingly simple phenomenon. The curiosity to question simple occurrences and the perseverance that takes to answer them is what sets scientists like C.V. Raman apart from the common man.
The light scattering experiments which he did actually arose from his love for nature, no doubt about it. But I would also like to point out that his early research in the Presidency College in the area of light, optics, has also contributed to his interest in light. And I would like to say that he is also a great admirer of Lord Rayleigh, who was an outstanding scientist of his time and who had himself had so much of love for nature.
And what is more, the discovery was made far away from the great centers of scientific research using simple equipments aboard a ship sailing in the Mediterranean Sea from Europe to Kolkata. In principle, Raman effect explores the scattering of light when it passes through a medium and explains that the blue color of sea is due to the scattering of sunlight by the water molecules, a phenomenon which is called molecular diffraction. When light beams falls on a liquid or a solid medium, some of the beams pass through, but a small part of the light is deflected and scattered in different directions by the molecules of the medium. Raman demonstrated that the wavelength of the scattered light is different from the wavelength of the original incident beam. This change in wavelength of the light beam on deflection by a medium is known as the Raman effect. Identified as one of the fundamental principles of optical physics, Raman's light scattering effect finds immense applications in today's digitalized world. Researchers and experts working in the area of pharmaceuticals, material sciences, petroleum industry and other chemical industries regularly use a technique called modern spectrometry. This is a method which uses the spectrum of the scattered light to understand the molecular structure and properties of the material under study. The technique is based on Raman effect. Similarly, the Raman scanners used to detect drugs, explosives, hazardous chemicals and gases is based on the principles of Raman effect. Raman lidar is used in atmospheric physics to measure the atmospheric extinction coefficient and the water vapor vertical distribution, so on and so forth. Honoring the discovery of this fundamental principle every year, February 28th is celebrated as National Science Day in India.
Well, that is all for today. We'll be back with fresh news stories on science and technology again next week. Till then, stay tuned to Rajya Sabha TV and think scientific all the time. Thanks for watching.